Good afternoon to all of you. Write down the first problem. Three statistically independent random variables x1, x2 and x3. x1, x2 and x3 have mean values x1 bar is equal to 3, x2 bar is equal to 6 and x3 bar that is equal to -2. Find the mean values of the following function. Find the mean values of the following function. A, g of x1, x2, x3 that is equal to x1 plus 3x2 plus 4x3. B, x1 into x2 into x3. C, minus 2x1 into x2 minus 3x1 into x3 plus 4x2 x3. And last one, D, which is given as x1 plus x2 plus x3. So in this problem they are given x1, x2 and x3. These are the three statistical independent random variables. They are having the mean value, that is expected value of x1 is equal to 3, x2 is 6, for x3 is equal to -2. We have to calculate the mean value for these four cases. Find out the mean values for first one, g of x1, x2, x3 that is equal to x1 plus 3x2 plus 4x3. We have to find out the mean value for first function. Here we will get expected value for this function g of x1, x2, x3 that is equal to expected value for this one x1 plus 3x2 plus 4x3. So we will get expected value of x1 plus 3 into expected value of x2 plus 4 into expected value of x3. Here 3 plus 3 into 6 plus 4 into -2. So we will get, what is the mean value? Is it 13? The mean value for first random variable, that is first function which depends upon three random variables x1, x2, x3 that is equal to 13. Similarly, you have to calculate the mean value for second function. Here expected value x1, x2 and x3. How to calculate mean value for this function x1, x2, x3? Can you calculate the mean value for this function? G of x, which is given as x1 multiplied with x2 multiplied with x3. Please read the problem. First statement is we are having the three random variables x1, x2, x3 which are statistically independent. What is the meaning of statistically independent? When two random variables, here expected value of xy that is equal to expected value of x into expected value of y. When these two random variables x and y are statistically independent, then we can see that expected value of xy is equal to expected value of x into expected value of y. This is applicable for these three random variables. So here we will get expected value of x1 into expected value of x2 into expected value of x3. Here we will get 3 multiplied with 6 multiplied with minus 2. That is minus 36. Similarly, you have to calculate mean value for this third case. Minus 2 x1 into x2 minus 3 x1 into x3 plus 4 x2 into x3. Here we will get expected value for this third case. We will get minus 2 expected value of x1 into x2 minus 3 expected value of x1 into x3 plus 4 expected value of x2 into x3. As these three random variables are statistically independent, here expected value of x1 into x2, that is equal to expected value of x1 into expected value of x2. Similar case for this one. Similar case for this one. Just calculate mean value for this third case. Minus 66 minus 66 and last one 7. Expected value of x1 plus expected value of x2 plus expected value of x3. This will give us the 7. Is it clear to all of you? So write down next problem. Write down two statistical independent random variables x and y. Two statistical independent random variables x and y have mean values x bar is equal to 2, y bar equal to 4. They have second moment x square bar, that is nothing but expected value of x square equal to 8, and y square bar is equal to expected value of y square is equal to 4, sorry, is equal to 25. Then find A, the mean value, B, the second moment, and C, the variance of random variable. The variance of random variable W is equal to 3x minus y. 3x minus y. So in this example, we are having the two random variables which are statistically independent. Mean value for x, that is equal to 2, mean value for y equal to 4. Then second moment about the origin, expected value of x square, that is equal to 8, and expected value of y square, that is equal to 25. Or this new random variable w is equal to 3x minus y, we have to find out its mean value, then find out its second moment, that is expected value of w square, and finally we have to find out what is the third case, variance of the random variable w. First of all, we have to find out this w bar, then we have to find out this w square bar, and we have to find out this sigma w square. Just try to find out these three values or new random variable w, which depends upon two random variables x and y. X and y are statistically independent. So for first case, to find out the mean value, expected value of w, that is equal to expected value, w is nothing but 3x minus y, then we will get this 3 into expected value of x minus expected value of y. So here 6, this is 3, mean value is 2 minus 4, 6 minus 4, that is equal to 2. So in this way we will get this w bar is equal to 2. Then for this second moment, expected value of w square is equal to expected value of this 3x minus y square. This will give us expected value over 9x square minus 6xy plus y square. So here we will get 9 expected value of x square minus 6 expected value of xy plus expected value of y square. Second movement for x, which is given 8, here 9 multiplied with 8 minus 6, then plus this y is 25. Then find out the value of expected value of xy. How to calculate this value? Expected value of xy is equal to expected value of x into expected value of y. Because these two random variables are statistically independent. This will give us 8. Then we will get this expected value of, what is the final answer? 49. Similarly, you have to calculate this sigma variance for this w. What is the variance for this one? Now in third case, we have to find out expected value of w minus w bar square. W minus w bar square. This is the second movement about mean. Here mean value is given by w bar or expected value of w. W minus w bar square. That is given as expected value of w square minus expected value of w square. So here expected value of w square 49 minus this w mean value square. This will give 45. This is nothing but sigma w square. Write down two random variables x and y. Two random variables x and y have means x bar is equal to 1, y bar equal to 2, variance sigma x square equal to 4, sigma y square equal to 1, and a correlation coefficient correlation coefficient equal to 0.4, new random variables v, that is equal to minus x plus 2y, w x plus 3y, these are the two random variables. Then find a, the means, b, the variances, c, the correlation, and d, the correlation coefficient, that is rho vw of random variables v and w. Correlation coefficient rho vw of random variables v and w. So in this example we have to find out this correlation coefficient. Then your v bar, w bar, sigma v square, sigma w square, then your correlation, that is rvw, and finally we have to find out the correlation coefficient for these two random variables. Simple. V bar, expected value of minus x plus 2y, that will give minus expected value of x plus 2 into expected value of y. X is given 1, y bar is given 2. So mean value for v 3. So here we will get v bar is equal to 3. Similarly, you have to calculate this w bar. Mean value for the second random variable w, which is a function of x and y. Expected value of x plus 3 into expected value of y. W bar is equal to 7. Now calculate variance for v and variance for w. So here we have to calculate the variance for this random variable v, which is given as minus x plus 2y. So this is nothing but expected value of v minus v bar square. So here we will get expected value of this v square minus 2v into v bar plus v bar square. This is given as expected value of v square minus 2 into expected value of v into v bar is nothing but expected value of v plus here v bar square. So expected value of v square minus 2, expected value of v, we have calculated 3. That will be given as 9 plus expected value of v square 3 square. Here 2, okay. Then here we know v bar, minimum value over this v bar. Unknown quantity is expected value of v square. So for this case we have to calculate this expected value of v square, that is equal to expected value of v is nothing but minus x plus 2y square. Just solve this one. Expected value of minus x plus 2y square. Square it. 4xy plus 4y square. Expected value of x square minus 4 into expected value of xy plus 4 into expected value of y square. How to calculate this expected value of x square? Sigma x square, that is equal to sigma x square minus sigma x square. This value, expected value of x square is 5. Similarly, how to calculate expected value of xy? Here, correlation coefficient or this xy, that is equal to covariance of x comma y to the sigma x into sigma y. Sigma x into sigma y. This covariance, that is given as expected value of xy minus expected value of x into expected value of y divided by sigma x into sigma y. Is it clear? Here sigma x, that is standard deviation. Sigma x square is 4, sigma x is 2. Sigma y square is equal to 1, sigma y is 1. Expected value of xy, that is your correlation function, minus expected value of x into expected value of y. This is the mean values, 2 into 1. Just equating these two equations, that is equal to 0.4, we will get this expected value of xy, that is equal to 2.8. So, for calculation of sigma v square, just we have to apply variance for this v is nothing but v minus v bar, that is expected value of v square. Just square this value. Here we will get expected value of v square. To solve this v square, we are having minus x plus 2y square. So here we will get expected value of x square minus 4 into expected value of xy plus expected value of y square. We can calculate this expected value of x square, that is the second moment about the origin. We can calculate by using the definition of this sigma x square, that is equal to expected value of x square minus expected value of x square. Similarly for y, that is given as expected value of y square minus expected value of y square. In this way we will get these two values. Here expected value of xy, this is nothing but correlation function. We can calculate this correlation function by using this correlation coefficient, that is equal to covariance of xy divided by sigma x into sigma y, that is standard deviation. So here we will get expected value of xy minus expected value of x into expected value of y divided by sigma x into sigma y. In this way we will get the value for expected value of xy, that is equal to 2.8. Just put these values, we will get the sigma v square, that is equal to minus 10.2, minus 10.2. Then this sigma v, here we will get this sigma variance, that is equal to minus 10.2. Similarly we will get this sigma v, that is a standard deviation, is equal to 3.193. Variance is always positive. This will give the difference. So here we will get minus 10.2. We have to consider this as a positive. So we will get the standard deviation for v. Standard deviation for v. Finally, you have to calculate correlation coefficient for these two random variables or this V and W. So that is given as, for this correlation coefficient is nothing but covariance with two random variables V and W divided by sigma V into sigma W. That's why we have calculated the standard deviation for V. Similarly, you have to calculate the value of variance for W. Can you calculate the variance for W? Is it clear? All of you? Balcony? Can I repeat? So see here, in this problem, we are having two random variables x and y. By using these two random variables, we are having new random variables, that is v, that is equal to minus x plus 2y, and w is equal to x plus 3y. Over these new random variables, we have to find out the mean for these two random variables, that is expected value of v and expected value of w. Then we have to calculate the variance, that is sigma v square and sigma w square, variance for these two random variables. Then we have to find out the correlation function for these two random variables, that is expected value of vw or rvw. This is the correlation. Then we have to find out the correlation coefficient, that is rho vw, which is given as covariance of v comma w divided by standard deviation for v and standard deviation for w. These are our target. To calculate this one, first of all you have to calculate the mean values. These are the simple. Expected value of v, that is equal to minus expected value of x plus 2 into expected value of y. We will get the mean value, that is equal to 3 and 7. Then we have to calculate the variance for v and w. So variance, expected value of v minus v bar square, this is the second movement about the mean. So here we will get sigma v square, that is equal to expected value of v minus v bar square. So here just square this value, expected value of v square minus 2 into v bar plus v bar square. Operate this expected operator, expected value of v square minus 2 into expected value of v into expected value of v plus v bar square. So here expected value of v square, we know mean value for v, that is given as 3. We can calculate these two terms, but for this first term, expected value of v square, which is given as, v is unknown for us, but v is in terms of x and y. So expected value of v square, that is equal to expected value or this minus x plus 2y square. Square this bracket term, x square minus 4 into xy plus 4y square. So here expected value of x square minus 4 into expected value of xy plus expected value of y square. Here these three expectations are unknown to us. Then how to find out expected value of x square and y square? By using the definition of your variance. So variance for sigma x square, which is given as expected value of x square minus expected value of x square. This is the second movement about origin, x square, expected value of x square. This is the second movement about your origin. This can be given as m2 minus expected value of x. This is the first movement about your origin. This will give the mean value. So here we will get m1 square. So expected value of x square minus expected value of x square, that is equal to 4. Mean, which is given as 1. Expected value of x square minus 1 square is equal to 4. So we will get expected value of x square is equal to 5. Similarly, we can calculate the value of expected value of y square, second moment about the origin for your random variable y. This comes to be 5. Is it clear? Now for third case, first variable, that is expected value of xy. How to calculate this expected that is expectation of xy? This is nothing but correlation function, that is expected value of xy. Either it is 0 or when two random variables are orthogonal to each other, this value becomes 0. When two random variables are statistically independent, then expected value of xy, that is equal to expected value of x into expected value of y. In this problem, are they mentioned these two random variables are statistically independent? Can we apply this term? But they are given the covariance, that is coefficient of correlation, rho xy, that is equal to 0.4. This correlation coefficient is nothing but covariance of random variable x and y divided by their standard deviation, that is sigma x and sigma y. We know this value. The covariance is given as expected value of xy minus expected value of x into expected value of y divided by sigma x into sigma y, that is equal to 0.4. Here this quantity is unknown. Sigma x standard deviation, which is known, that is the square root value of variance 2. Then sigma y, square root value of variance y, that is 1. Mean value, which is given as 1 and this one is 2. In this way we can find out expected value of xy, that is equal to 2.8. So in this equation we have to put these values. Expected value of x square 5, this one is 2.8, this one is 5. So we will get finally sigma v square, and their square root value gives standard deviation. Similarly, you have to calculate the variance value for w. Finally, whatever the correlation coefficient we will get for this VW, this one, its range is -1 to 1. Its range, this correlation coefficient is ranging from -1 to 1. When this correlation coefficient is equal to 0, we can say that these two random variables are uncorrelated to each other. When this correlation coefficient is equal to 1, then we can say that this correlated to each other. Then -1, negative correlated. Now for variance for W, see here, variance for W, which is given as expected value of W minus W bar square. W minus W bar square, this is nothing but expected value over this W square minus 2 W into W bar plus W bar square. Now here expected value of W square minus 2 into expected value of W into W bar plus W bar square. Here we will get expected value of W square minus 2 W bar square plus W bar square. So we will get expected value of W square minus W bar square. Here W bar is nothing but mean value for this W, 7. Here we will get expected value of W square minus 49. Now we have to calculate this expected value of W square. This W is unknown for us, but this W is the function of X and Y random variables. So we have to put here expected value for W is given as X plus 3Y square, expected value of X square plus 6XY plus 9Y square. So we will get expected value of X square plus 6 into expected value of XY plus 9 into expected value of Y square. So here expected value of X square 5. Is it correct? Expected value of X square. Second movement about your origin for the random variable X, 5 plus 6 multiplied with expected value of XY, 2.8 plus 9 into expected value of Y square, 5, 45. What is this value? 66.8. Then here variance value we will get 66.8 minus 49. What is the final value? 17.8. Okay. So in this way we will get the value for sigma W square and sigma W. Is it okay? Correlation coefficient for this random variable V and W, that is given as covariance over this V comma W divided by sigma V into sigma W. So here covariance for V and W is given as expected value of VW minus expected value of V into expected value of W divided by sigma X into sigma Y. Here expectation or V is nothing but minus X plus 2Y, then W is X plus 3Y. Just multiply it. So here this value comes to be 22.2. Expectation of VW is comes to be 2.2. When we put for this correlation coefficient, I got this value is 0.07977.